Okay, so in the 6.9b video, we ran into a problem when we did this one, so I just want to redo it and explain why that mistake was happening on the calculator. So when we previously did it, for this, it was talking about the average price, I believe it was, of a house in northeastern United States for 1987 to 1995. Now in this one, it does not specify let X be the number of years since 1980. Okay, so the reason the problem happened on the calculator is because of the such large numbers for X, that the calculator was not able to do it. So to fix that problem, we're going to change this up a little bit and say let X be the number of years since 1980, and that is the values we're going to plug in to our calculator. So if we look through here, let X be the number of years since 1980. The first one, 1987, that's going to be 7 years from 1980. 8, 9, 10, 11, 12, 13, 14, 15. So those are the values we're going to use for list 1 when we enter it into the calculator. And then this should fix the problem that we had in the previous video. Okay, so let's go ahead, let's bring in the calculator. And again, we're entering statistics, so we're going to hit the stat button, edit. Okay, and there's the values that we had there. We're going to clear those. Okay, and actually those are the values that we had, so we're going to leave those. So for list 1, instead of the 1987, 1988, 1989, we're going to enter 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, come test time, we're going to make sure that doesn't happen. Probably a good thing to remember is we'll probably say let X be the number of years since. So make sure that you're adjusting those list values properly given the directions. Okay, so again, now we have that. Let's just go ahead and let's double check that we have it. 7 through 15, 140, 149, 159.6, 159, 155.9, 169, 162.9. Okay, we are good. So now that we double checked our list values, we're going to do our scatter plot. Okay, and again, in order to do that, you need to make sure second plot, you have your scatter plot on. Once you get that, you hit graph. And again, the window might not show up properly on there. In order to fix that, you hit zoom stat. Okay, on the TI-84s, it's going to be a little bit different. And then, so hit zoom stat, zoom 5, which I believe it's zoom, 9 on the calculator. Okay, I have another graph in there, so let's go ahead, let's clear that. Hit graph, and it should bring up our scatter plot. Okay, so then from there again, quadrant 1, and you're just going to do exactly what you have there. So we got just plugging those points into where they should be. Okay, so there's our scatter plot. Again, we need to have our labels. X, which was the number of years since 1980. And then F of X, which was the average price of a house. And we'll just say average price. And that was in terms of thousands. And from there, again, we're going to hit window to get our X max, X min. So X min 6.47. We'll go to the hundredths place there. And X max, we got 15.53. Y min, we got 137.33. And then Y max 182.67 if we go to the hundredths. Okay, there's our scatter plot. Now again, when looking at this, we have to determine what type of regression we're going to run. So when I do this, I look at the M behavior. We're going in opposite directions. So in our case, we're either running a linear regression or a cubic regression. Okay, so what you're going to do is you're really going to run both of them. Okay, so in this case, stat, calc, let's check the linear regression. Okay, and we got list 1, so I need to clear that. You shouldn't have to worry about changing the lists at all. But we had list 1, list 2 where our information was. calculate. And what we're going to look at is the correlation coefficient. Okay, for the linear regression, it was at 0.9179 or 0.9180 actually when we round to that 4 decimal places. So let's see if our coefficient of determination is better with that cubic regression. Okay, so run that cubic regression, we get that correlation or coefficient of determination of 0.9204, which was better than the linear regression, so we want to use the cubic regression in this case. Okay, so cubic regression, and then just writing out the equation then, 0.2417x cubed minus 8.0702 x squared plus 90.9119x minus that 184.0667. Okay, so again, we had that better correlation or coefficient of determination, so that is the regression we need to use, and that coefficient of determination was 0.9204. Okay, so when you're doing these, make sure you pick the proper regression. In this case, it was a cubic, and the reason for that, just think if you drew a line through here, again, if it's a scatter plot, so you shouldn't have this on your linear regression, but it's like we got some turning points in there. Okay, since there's turning points, it probably is going away from that linear regression, so we needed to run a cubic regression in that case. All right, so if you have any questions, make sure you let me know. Otherwise, have a good day.